Yeah, hi all. So this is recursion part 2 video. We'll try to solve 4 to 5 questions in this. And today my typing speed will be a bit slow because as you can see, I'll be coding in Linux, like in Linux environment, and I'm using nvim edit. So in this editor, like especially like if I try to show you, yeah, this is how the editor here it is. The main part of this is that we have to control most of the things with keyboard itself, and we can use mouse. I have made some settings so that I can use the mouse, but I will try to avoid it because I want to learn this nvim editor. Okay. So yeah, my typing speed may be a bit slow. There might be few errors, but okay, that's fine. So let's proceed with the first question. That is, remove duplicates in a string. Let me try to explain you what this question says. Let's say I have something like A, B, C, C, D, A. So if you see here, what are the duplicates? A is duplicate here, and C is duplicate. Okay. So now what is your task? Your task is to write a function. Okay. Let's say this is a function. When you pass this string to this thing, it's going to return you what? A, B, C, D, only this much, A, B, C, D, because it's going to remove the duplicate things, that is this C and this A. Okay. How would you do it? Like, what's the logic here? You have to simply go character by character. So initially you'll start with, let's say 0. Okay. Then you are going to go to the next character. Like first by default, like nothing is present here before this. So you are automatically going to, let's create one more variable, and you are automatically saying that if nothing is here, then A is being stored. So A is pushed here. Okay. This is what our new string. Let's say new string. Then after this 0, you are updating the index and sending back to your function. Let's say this will be 1 now. Like initially it was, so here it is index. You are also passing index. So first you pass 0. Then again, next time you are passing 1. Then this B is going to check if B is already present. And here there is no B present. So what is happening? Even this is being added. So here B is added. Same thing with C. Now you are updating the index and passing next thing. So the index value will be nav2. The string data will be passed this thing. Whatever is there, this will be passed every time. So now when the string index is 2, that is, it will take this C and it will check if it is already there. So there is no C already present. So it is going to add C here. Then as soon as it goes to the third index, what we got, we got one more C. And when it checks back, it gets to know that C is already present here. So it's not going to add it. Okay. And it goes to D and it simply adds D and it will not even add A. So finally, what we got from this entire thing, we are able to get A, B, C, D, and this is what we are going to return. Okay. Few things are clear. What is clear? That one thing is we have to always pass string in our variable to keep a note. Second thing is we are always updating the index and passing. So this is nothing but if you consider index as n, then index the next time when you recursively call this function, you are simply passing n plus 1. Cool. Now, the main black box that is left is how is your logic happening? Like how are you going to check back for the rest of this? So this is the logic for like what? For if condition, you can say. How are you going to check if it is already present? For this, again, what we'll do is we'll pass one more argument for our this function. So that argument will be nothing but, let's say, a array. Okay. What this array will contain? This array will contain the text values from 0 to 26. Why? Because actually it's 0 to 25. Because we have 26 letters. Okay. So what are these acting? These are acting as a pointer now. Okay, pointer. What do I mean by that? That this 0th index of this array is nothing but pointing to A. Okay. The 1 index of this array is nothing but pointing to what? B. Okay, so in this way, I have up to 25, and this last index is pointing to Z. Okay, so this array is nothing but we can say it's map or array, whatever you feel, is also being passed here. So the third thing what we are passing is, let's say, a array. Okay, now as you are passing array also, the if condition is nothing but you have to like simply see now when you are adding this new string here. Okay, when you are adding this new string here, you have to add one more task. That is, once you have added this to new string, whatever is the letter that is A, it's adjacent, like its index that is 0. Here you have to simply say that it is true. So here it is true. Now here you got B. So here you have to simply say its adjacent is like its index is what? 1. And here you are going to simply say true. So that next time, similarly, let's do it for C also. C also, it becomes true. So next time when the C comes to check, like if it is already present, it first checks the index. Okay, it first checks the index. And in index, the position is already true for the next C. Okay, so therefore, it's not going to go to this path. Okay, it's not going to go to this path. Clear? Okay, few things are clear now. Like we got to know that we are going to update this TTT. Okay, the last logic is left. How to know what is the index of a particular number? Like how will I know that, let's say I get something M. How will I know the index of this? Again, this is somewhere related to 4th or 5th class where we did type conversion. Let's say if we convert A to int, we got somewhere that the value is 97. Hope I'm correct. Okay, you can just try to print it and check when we convert this A, what value you are going to. And similarly, then the next value of this would be like 98 and so on. Okay, so here we are getting these values. So now it's simple, right? So in my array, I'm going to simply say that whatever is this A minus, let's say A, this should give me what? 97 minus 97 will give me 0. Then I'm going to say B minus A. So this will give me what? 1. Clear? Because 98 minus 97 will give me 1. So similarly, I can do it for up to Z. And here I'll get from starting from 0 up to 25 because we have 26 letters. Right. So in this way, what we did, we have now a logic to find out the index of a particular character. Clear? So let's try to sum it up. We have a function, okay, which is going to take what? A string, okay, our original string. Then next one is what? It's going to take the current index at what it is. Then next thing is we are always passing the map. Okay. Then what is one more thing? Here we can pass string, or we can say we are passing string builder. I hope you know the importance. In last class, we have discussed why we have to, if we are doing some calculation or performing some manipulation, why string builder is used rather than string. Clear? So this string builder is nothing but our new string. Okay, clear. So these are the 4 arguments that we are passing. From here, we are getting what the final outcome should be. We should get a updated new string. New string. What can be our base condition? Our base condition can be that we know that our index is nothing but we are going on reducing, right? Or we can keep on increasing. So as soon as our index hits our the string dot length, so I can say if index is equal to string dot length, if this condition hits, then what I have to do, I have to return my new string. So I'll return new string. So this is what? This is my base condition. Okay. Yeah, hi. My internet went down. Yes. Yes, let's continue. So I guess we had discussed base condition and all. Let's start to code. static. We want to just display, right? Okay, static void. The function name is, let's say, remove duplicates. And what are the arguments we are passing? The first one is string, and let's say it is string data. Then comma. What's the next one? Is int index. Okay, comma. What else? String builder, right? String builder. And okay, string builder. Here I am going to say it is as new string. Then what else I want is comma map, right? So for that I'm simply saying this should contain Boolean value inside it. So Boolean, okay, Boolean, and what's the name? Let's say array, or you can say map. Let me say array. Define square brackets. Once we have defined this thing, what's our base condition? If index is equal to, let's say, str data dot len. If this happens, what we are going to do, we are simply going to display south new string, and then after displaying it, we are going to return. Okay, fine. This is the base condition. Now, what we have to do is write the logic. So here is the logic coming in. Good. I have to first get the current character. So let me say current character is equal to, this should be char. So this is the data type of char. Current character equal to what I can say is str data present index. Okay, so this will give me okay, this is what Java. So we have a function before that is char at present index. Okay, sounds good. Insert mode, go back to folder. Okay, this should give us current character. Sure, why there is okay, fine. Let's go with the next one. Insert. Okay, once we get the current character, we have to check like if the current character, I can't do undo also. For example, if I do undo, so it doesn't work. I'm not sure what's the shortcut here. Let me double D. Okay, deletes, insert, enter, up, tab, base condition that if current character, I have to get the integer value. So minus -a. So this is going to give me integer value. And this I have to check in array. So I have to wrap it in this and delete this. So I'm going to get current character. Let's say it is a for the first time. Then a minus a will give us 0. And I'm going to say array of 0. Array of 0. If it is insert mode control okay, see there. Here is equal to 0. If this happens, then curly brackets go to the next line. Sorry, it's not 0 actually, it should be true, right? So this is true. If it is true, that means what? The position is already taken. Okay, so in case if the position is already taken, then what we have to do is we have to call the same function, that is remove duplicates. String data will be same. Index will be what? +1. So insert mode +1. New string, we won't do anything with the new string, and array is also fine. Okay, then insert mode here, then here I'm going to say else. What is the meaning of else? That means this is false, that A is not already present. So then what I have to do is first I have to say array of that position, that is nothing but current char minus quotation A. So this position, first I have to fill it with true. Okay, after filling it with true, then what I have to do, I have to call the same function, remove duplicates. But this time what I have to do is I have to say index plus one. This is same thing, index plus one. Whereas in new string, I have to add it. Now, if it was simple string, then I could have done plus and added, but this is string builder. So I'm going to use append character. Oh shit, you see? No, I can't do control, so I have to do it. Append tab, and this is it. What I have to append? Current, wait a second. New string, so new string, nothing will happen. Current character, I have to current character. So I hope this should work. Let's see if it works. Okay, so normal mode. Insert, enter. The function remove duplicates. Okay, the weird thing about this NVM editor is that enter won't work. You have to do tab, remove duplicates. So for the first one, I'm going to say new string. What's the string? Let's say the string is Sri Khan. Okay, fine. Index, I'm going to keep it as 0. This I'm going to change it. So here now, if you see, there is a shortcut to do, that is CIW, change in word. And now what I have to do is again new string builder, the second one, tab, yes, tab. What's this? Initially it is empty, and this is what? Array, right? So for array, again, I'll say change in words. Oh, it was in insert mode, so it will come. CIW, okay, changed. New, what? Array, square bracket, 26. So it's a length of 26. Cool. Hopefully it should work fine. Let's see if there is any error. It's okay. This should be changed. This should be array of 26. Okay, fine. Yeah. Cool. Okay. Let's see if it works. So I have to first write the changes. Okay. It is written, and I'll shift first. And here I have to first compile. So Java C compile what? Recursion part2.java. Yes, no errors. Then I have to simply say Java recursion part2. And exception is that Java index minus 14 out of 1. Okay, I got the issue with this. Let me switch back to first time. Yes, the issue is I have passed here capital S. Yeah, that's the issue. Here it should be just small s. Why? Because the capital S value is less than small s. Maybe for that reason, when it is subtracting, it's giving an issue. For capital, if you want to make the capital also work, you have to just make sure your Boolean data and this part is correct. Okay. So let's move to, okay, I have to first write the changes. Control W, right? Then move to this tab, compile it first. Then the question part 2. Okay, if you see, the E is removed. Okay, let's check it for few more things. Then I'll do C, I, W, change in word. A, B, C, C, B, G, C, D, E, F, F, E, A. So this is something I have written. Control, right, enter, second tab, compile, and run. Okay, A, B, C, D, E, F. Yeah. So this confirms that our function is working, remove duplicates is working correctly. Okay, let's go to the next question. What is the next question? Tiles problem. Okay, let me explain what this question is asking us to do. We are provided with a question that 2 into n is the place. For example, this entire thing is this height, or we can say, yeah, height is 2. This n is unknown. This is what we are going to get from our function. Okay, this n is unknown for us, and we are given with the tile. The tile length is, let's say, the height is 2, and the width is 1. Clear? So our logic, like our question, tiles problem, is asking us to find out in how many ways can we place the tiles inside this. Okay, for example, let me put this, call this here. Okay. I'll change the color to red. So 2 into 1. So the tiles can be fixed for the, like in the one way is you can fix it in this way. This will occupy how much? 2, and here it is going to occupy 1. Or the other way is you can fix it in this way. If you fix it in this way, then this is how much? This is occupied as 2, and this is occupied as 1. So if you are going to fix it in this way, then you have to always make sure that you are also fixing here one more time. So there can be various ways, like so first way is you started this, then the second way can be like this. First this, then this, and then you place it like this. So here we are, let's say we have passed the number n as let's say 3. So that is nothing but 1. This is 2. So 1 plus 2, this total length is what? 3. Okay. So this total length is 3. So we found out that there is one way here. This is the one way, that is 1 long. And here, like width-wise, I can say. Here it is how? Width first, and then it is long. Then anything else? Any else combination? Yes, we can do everything in this way. That is, everything in long. So long, long, long. So like everything. Apart from that, there is no other way in which we can combine our tiles. Okay. So how many ways we found out? That when we give the function, let's say this is our function, and if we pass 3 to this, it should give us what? 3, saying that there are 3 ways. Clear? So this is our what? Tiles problem. This is the question. Okay, clear? Let's try to do it for a few problems so that we get some logic from here. Let's say when the n is 1, then what's happening? That our position is like 2 into 1, and how many ways we are there? There are only 1. Yeah. Then okay. Now when n is 2, so we are provided with a box like this. So here 2 and here 2. So the only way for this is, one is if you can place it here, then you have to place the next tile also like this. Or else, in case if you place your tile like this, then you have to make sure that the next tile is also placed like this. So how many ways are here? There are 2 ways. For n equal to 3, we calculated there are how many ways? 3 ways. Clear? Okay, so we are able to do it for 1, 2, 3. Now let's focus, like if we have like this, which is, this is 2, and this is n. How to calculate for this? Okay, So again, like if you remember the last class, let's assume that we have a function. Okay. When we pass this function, the n, it's going to give its correct value. Like in case if we pass it 1, it's going to give us the correct value, that is 1. If we pass it 2, it's going to give us 2. If it passes 3, then it's going to give us 3. So this function is correct. Let's assume that. Now, what we are passing here, for this function, we are first passing n. Okay. Now, when we pass n, this function has two choices to take. That is, first, it can place the block vertically, yeah, or else it can place the block horizontally. Clear? Now, in case if the function chooses to place the box vertically, okay, let's say it has placed it here. Now, what the function should do, it should calculate for this part. Okay. And this is what, so here it is 1 because we know its dimension that this is 1. So what is the dimension of this part? The dimension of this is nothing but n minus 2. So now I have to calculate the number of ways that can fit the tiles in this way. And I already have a function which does that work. So I'm going to call this same function, but now I'm calling it for what? For n minus 1. Okay, n minus 1. Yeah. But what if it chooses this horizontal way? If it chooses horizontal way, then how many ways we are left with? If it places it like this, then here we know it occupies the 2 space and it can't place here. So the remaining part, that is this part, what is the dimension left? That is nothing but n minus 2 because 2 is already occupied. So now the function should calculate for n minus 2 ways. How many ways, like how many ways tiles can be placed? I already know that there is one function which can do that. So I'm going to call this function, that is n minus 2, and find out how many ways can n minus 2 tiles can fit. Clear? Okay. So once I found out for this n minus 1 and this is for n minus 2, now the total ways is nothing but I have to sum this and this. So I'll add this. And what is this? This is nothing but calling the same function. Clear? I hope it made some sense. If not, like let's try to code it and see if it's we are able to understand. Let me say let's go to recursion part 2 Java, enter. And let's say, okay, they are in correct line. And here I want to insert node, tab, and static. Do we want to return integer value? Yes, we want to return integer value. And I can say tile calculate. Something called tile calc. Okay. What is the argument we are going to get? We are going to get only one argument, that is n. Okay. Now, what is our base condition? We got to know that if our number is n is less than or equal to 0, we know that it is always 1. So that we can treat it as our base condition. Which can say return what? 1. Okay, fine. Now, once we are returning 1, what we found out that we have to, like this function, what we'll do, this function needs to call a function. Let's say that function is tile calc, and it will just find out for n minus 1 ways, plus it needs one more function that is nothing but tile calc, and this is going to find out for how many ways? N minus, yeah, and whatever is the total answer that we are going to simply return. So n minus 1 plus n minus 2 tile calc will be returned. So return, and I have to give insert colon. Okay, fine. So yeah, this is the function which calculates the total number of tiles. Let's check it. Here I'm going to say GCC. This is commented. Insert node. Reset tile calci. Teach insert and go tab. Call the function, but before that I have to do south because we are returning, and inside this I have to say tile calci. Let's first pass 3 and check if we get the answer as 3. So write it. Go to second screen. Java C part 2. Okay. After compiling, okay, it's returning as 5. Let's see why. Yes, that's because your the base condition I wrote it as 0, whereas it should be 1. Insert 1. Okay, now it should work fine. Control W, enter. Go to second tab, compile it, run it. Okay, if you see it's 3, let's check for okay, let's check it for 4. 4. Escape. W, right. Go to second tab, compile, run. It's 5. Clear? You can check out how the 5 comes. Just try to draw the tree map. You will get to know how it works. Okay? So once we have understood this problem, let's go to the next one. That is question number 2, friends party question. Okay. In this, let's imagine like we have visited one party, and the rule of this party is that a person can be either single or he has to be in a pair. Like there should be, let's say A is there, and pair is nothing but let's say B, C can be in pair. There are the only 2 ways, like you should be at least in single way, or you should have B, C. Okay, let's say there are 4 people now, A, B, C, D. What are the possible combination of this? The possible combination can be all are separate, A, comma, B, comma, C, comma, D. Then next thing is A can be separate, B can be separate, then we have C, D as one thing. In this way, we have to calculate in how many ways is possible to have this. In how many possible ways we can have the peoples in this party. Okay. This is again like somewhere permutation combination thing related to maths. If you know it, it's very easy for you. If not, you have to just try to think once more and like try to solve it. You'll get to know it. Cool. Let's first again do it for let's say when it is just one member, then there is only one way. That is, let's say if it is A, then there is only one way, that is A can be there. If there are 2 peoples, let's say this is what? This is N I'm writing here. If there are 2 peoples, that is A comma B, then how many ways? There are 2 ways actually, A comma B, then they can be either in group. So here it is 1 way, here it is 2 way. Now, let's say if there are 3 peoples, that is A comma B comma C, then in how many ways it is possible? First is the all can be separate, B, C. Okay, then it can be A, B, C can be here. Then B can be single and A, C can be pair. And C can be single and A, B can be in pair. Anything else? No, right? Okay. So here if you see there are 4 combinations. 1, 2. Okay. Cool. Clear. So now we have to come up with a function which does this calculation. Let's again imagine we have one function which already does this task. We are not sure how it does, but we already know, like if we pass it 1, it's going to return us 1. If we pass it 2, it's going to return us 2. If it passes 3, it should return us 1. So this function already knows it for it's going to do that. Now, let's say we have passed how many n members. So here what I'm going to do is, let's say I have passed now n. Let me change the font with color, and I'm saying we have passed n. Okay. Now, once we have passed n members inside this, now what this function should do, this function has how many choices to make? This function has two choices to make. One is it can think like a person is single, or else it can think like if that it is in pair. Okay. Now, if it is a single, and then what does it mean? That our n minus 1, right? If it is single, that means we have to find out the number of ways for n minus 1. So this is nothing but, like, let's say here again we know that there is one function which does this work. Let's say this function is over, and for this fellow we are saying now do the same thing, but for now calculate for n minus 1 people. Okay, so it will try to calculate for n minus 1. That's fine. Let's keep it here. Then what if he chooses pair? So if he chooses pair, then 2 people will be vanished from our n. So we have n minus 2. Okay. Now we have to calculate for how many ways? N minus 2 ways. But we have to make sure that this n minus 2 will be multiplied by our n minus 1. That is n minus 1. Why? Okay, clear. But what is the logic of this? Why we did this? You can imagine, like, let's say there are a bunch of n, a, b, c, d, e in such way, and there is n minus 1. Let's say the external player is z. Now the combination, this will give us number of pairs. So this is nothing but, like, let's say if we took ZA, now this is, it's not necessary that it can be just A, it can be also B, right? Or it can be also C, same with D. So in this way, like, we can have bunch of combination. So for this same thing, what we did is we are multiplying with n minus 1. Now to make this concept much clear, like, you have to visit, let's say, permutation and combination, like PNC and all. Just try to go through it once and you will get to know it. Okay. Or once we move to dynamic programming and once we have a bit of practice, much more, this will be easy to understand. Okay. So let's clear the screen and move to the code. This is actually in my virtual machine, so I have to keep on doing this. Okay, let's go to Control F, part 2. Okay, enter. Now Control F. Okay. Here, insert. Tab. Now I'll say static. Okay. Do I have to return something? Yes. And we are going to return number of ways. Then I can say party pairs. Okay. We are going to get what? Int n. That is total number of people in that group. And inside this, I'm going to say int. Not int. Sorry. If n is equal to 1, what we know, or n is equal to 2. We already calculated for this. That is, if it is 1, there is going to be only one way. If there are two peoples, there are only going to be 2 ways. That is, they both can be separate or they both can be in one pair. So here we are simply going to return what? Return n based on whatever it is. Cool. Now, the next thing is to calculate the party pairs. So here what we said, we first of all, let's say return party pairs. First calculate for, let's say if it's already single, one person choose to be single, then we need to have a function which will calculate for n minus 1 pairs. So we already have that function that is nothing but party pairs. Then plus this with what if it chooses to be go in pair? Then if it chooses to go in pair, we need to say party pairs, calculate for n minus 2 pairs. So n minus 2. So it will calculate for n minus 2 ways. After calculating for that, what you do, multiply it with n minus 1. Let me put this in parentheses. Not this. And clear. So this fixes our question most probably. Let's call this function. Changing word party pairs. Okay, that. So let's write the function. Control W, write it. Okay, if you see the code is very simple, writing it is simple, but understanding behind the logic is but struggle thing, like you have to understand. The only hint or this I can give right now is don't try to go into how the internal thing is working. Just try to find out the relationship thing, like what's the relation, how it's again calling inside. Just try to find that relation. Now here, if you see in this problem, the 8th line is most important. Like if you found out the relation, what you have to do, then you have to simply call that same function again and again. Internally, it will take care of its own. Right? If you still want to interest like how it's internally happening, then in last class I had explained, right, like drawing the trees. In that way, you can simply draw the trees and you can get to know how this is happening. Okay. Fine. Let's see if it's working fine. Control right. Go to next tab. Recursion part 2. Okay, it gives us 10 ways. So if there are 4 people, it gives us 10. Let's check it for insert, check it for how many ways? 3. So for 3, how many we had? 4, I guess. Control the do this. See 4. So yes, this confirms our recursion is working fine. Now control F, go to question text and binary start. Okay. So moving with next question, that is binary string question. So here, the logic is that they will be giving you a number. Let's say they gave you the number as 2. What you have to do is you have to find out the total number of ways in which you can place the binary numbers, that is nothing but 0 and 1. But you have to make sure the condition is you can't have adjacent. For example, now if 2 is being passed, let's say if 1 is being passed, there is 2 ways, that is it can have 0 or it can have 1. So the answer for this is 2. Now in case if they pass 2, then what are the possible ways? The first one is it can have 0, 0. The second one is it can have 0, 1. The third one is it can have 1, 0. 1, 1 is not possible. So total number of ways is what? 3. Clear? Now, we need to write a logic to calculate, like to display these numbers. Clear? Okay, so how to do this? Again, let's imagine we have our black box, which does this thing, weird thing. Now, what's the relationship? Okay, first of all, base condition, I can say that whenever it is 1, gave us, let's say 3 or 4. What is this? This is n. So we are going on reducing it, and you know somewhere we are going to reach 1. So I can write a base condition as if base condition, like if it is 1, return, like simply return. You are not going to pass something. It will be a void thing. So we have to shout it. That is nothing but we have to display and then we have to return. So this is something a base condition. Then how to call this function. Uh, Once the base condition is clear, so what may be the possible arguments for this? Let's say we are first passing what? N. Okay, this is the common thing, like main thing. So we are going to pass our N. Okay. Then what else we are going to pass is the last position I can see, or current position, whatever it is. Why last position? Because we have to keep a track of this. Like if here it is 1, then we have to make sure that our function is not being called and we shouldn't get this thing. Like we shouldn't place 1 here. For example, if n was 3. So if our n is 3, then if in case here if it is 1 in first position, if this case occurs, we have to make sure that here our function is being called only for 0 and not for 1. Okay, so what can be the condition for this? The choices for this is that if last position is 1, then call the function for to display 0, that is if to add a 0. Okay, if it is 0, then here what it can do is it can call two functions. Let's say this function will call 0 and this function will call 1. Clear? Okay, let me try to recap it. Like here we have two choices, like the last position, that is nothing but this, can be either 0 or 1. In case if it is 1, then call this function. What is this? This is a function, the square bracket is function. Call this function for only 0. What is 0? Like let's say we are passing here one more argument. This is a string and we are adding. In future, we'll be adding either 0 or we'll be adding either 1. Here what we are doing is we are calling the function and we are adding 0. Okay. In case if the last position was 0, then inside this we again have two choices to make, that we should call it for 0 or we should call it for 1. Okay, so here what happens is the actual again recursion happening. Again, it's calling again and clear. Okay. I hope like the explanation is making sense, or recursion explanation is a bit weird, I guess. Let's go to the coding thing. Let's try to code it once. Say 4 dot enter. Okay. Insert tab static. Okay. Are we displaying, like we are displaying red? So I'll say void binary history. What all arguments we require is, let's say we require a string. Okay, so initially let's say str. Let me do it str data, comma. What else we require is how many positions. So I'll say int n, comma. Anything else? Yes, we need to note the last character. So I can say, what is that? I can simply say char. Okay, and here I can say last char. Good. So these are the arguments. Now, in case if n is equal to let's say 1. Okay, if this happens, then what we have to do is simply solve str data. Okay, and we have to simply return from here. This is my base condition. And else, what I have to do is have to keep on calling my binary this function. Here string data, what I can do is initially okay, I can say string data plus 0. Okay. And n will be what? N, let's say -1. Now, last char will be what? Last char will be, let's say, change in word. Oh shit. Last character will be passed as 0. This is actually okay, 0. Clear? Now here I'm going to write the condition if my last char is equal to, let's say, quotation mark 0. Like if it is 0, then what I can make, I have a choice to call this function again, binary this string data, and here I can make insert, and here I'm going to add plus quotation mark 1. Okay, and n will be again -1, and last char will be what? Let's change this to last char will be 1. Clear? Now let's call this function. So let's say GCC and insert enter features call binary plus what I have to pass initially string data, right? So new there is nothing but initially inside this. I'm going to say insert empty quotation mark. This I'll do it for, let's say, 3. And initially what we are passing is, let's say, 4. Once this is done, let's write it into the right info. Move to next tab, compile this, run it. So we have 0001.0. Okay, so why is this 1? So most probably I have passed if condition as yes. If I just fix this as 0, then this should be sorted. Let's confirm. Enter, and now check it here. Good. So if you see, it's displaying properly as we discussed at the beginning of the class. So the same order and the same thing you are able to observe. So let's see how many problems you have done. 1, maybe 4. 1, 2, 3. Okay, cool. So these were the 4 problems that we were able to do with the help of recursion. Okay. It may slightly feel confusing, but as I said initially, just think your function is working and try to find the relationship. That's it. You will be able to do it. One more thing is that this gets complex when you have 2 things calling like this. What if you see, like here in all the functions that we did today, we are calling the R function twice. Okay, inside the function. If it was just 1, it wouldn't be that much what I can say, confusing, I can say. But here, as we are calling it twice, so you need to figure out like what's happening. And if you just draw the tree map of it, you will be able to get it how it's actually. Yep. So yeah, that's it with today's class. We'll catch up in next class. Bye.